All right. Welcome, one and all. Hello, greetings from Ottawa. I am your host, Aaron from Solace, coming at you live on LinkedIn, YouTube, and on Twitter for yet another office hours. I'm going to be here online for 1 hour answering questions and talking about all things Solace and event-driven. I'm very pleased to invite my special guest for today, Nick. Welcome to the stream.
Hey, Aaron. Thanks for having me.
How you doing, man? You all right?
Doing good.
Where are you joining us from?
I'm in the New York office today.
All right. Anybody else in? Or is it quiet?
It's quite quiet here. It's just me.
All right. I'm planning to go to the Ottawa office headquarters tomorrow with our VP of Customer Success, Dan Fossum, who lives a couple blocks from here. Should be hopefully see some other people in the office now that we're starting to come back at least a little bit, coming back in person. So, why don't you introduce yourself? Tell us who you are.
Yeah, sure. So I guess in terms of Solace, I'm a relative newcomer to the company. I've been around about 4 months now, but I originally come from South Carolina. That's where I was born and raised. I studied mechanical engineering there. I actually got a PhD in mechanical engineering. So I was in college for, 8 years.
A long time.
But like all things engineering these days, everything is software. And so after graduating about 11 years ago, got into software professionally. I've done things like QA engineer, .NET developer, and front end like a React developer as well. And what I currently do, sales engineering for Solace.
All right. Excellent. Well, hey, welcome to the stream. I like to try and pick different people from the field to join me. This is our first time doing it live together. So yeah, I hope it's good. So hello to everybody that's out there. I am Aaron, your host. Let me just throw up a banner here. What's going on? Banners. Where are you going to join us from? That's what I'm wanting to know. Let's see if I can. Oh my gosh, what's going on here? I got my banners all screwed up. There we go. Hey, where are you joining us from? Put it in the chat. LinkedIn, YouTube, and on Twitter. We should be able to get them here in the chat. Say hello. We're happy to join you. So typically on these office hours, we will kind of answer questions live on air. If you have them, we head over to our Solace community at Solace.community in your browser. It's our one-stop shop QA forum, Q&A forum for doing questions and answers, where we release kind of early access APIs and all sorts of announcements about upcoming products. So be sure to head over to Solace community. But before we get into that, Nick and I are going to do a little discussion around guaranteed messaging. A lot of kind of customers and use cases around Solace use guaranteed messaging. And how we handle streaming in the sense of the Solace protocol, how we are not doing kind of one message at a time, how acknowledgements and all sorts of transport kind of mechanisms are working inside the Solace protocol. So we're going to talk about that in just a second. Let's see, we got Mark joining. Hey, Mark. Hey, hello, welcome. Sunny Orlando, Florida. All right, thanks for being here. Good to see you. Whoever's out there, let us know. So, Nick, let's talk about this. Let me share it. Let me pull it up here. So, how did this actually come about? Because this is your diagram. How did you come about to kind of drawing this thing that we're going to show in a second?
Well, this actually was from a client discussion. So we were having kind of very detailed late sales engineering. We're talking about how the product works, and there was a customer who had a very specific need to ensure that messages were delivered at a particular time, absolutely guaranteed they were, delivered. Now, we do have a lot of collateral already on our site with regarding to how messages go from a producer up to to our brokers. But then on the flip side, it's actually very similar, but there was no kind of graphic or article explaining that. And so the conversation went on for quite a while. And then it came to a point where we said, we need maybe some visual analogy, or as I like to call it, a cartoon, quite literally a cartoon, to kind of explain this in ways that are not, of course, 100% faithful to what goes on behind the scenes, but just a way to kind of grasp. We have, several settings and parameters and adjustments you can do when you use the APIs. And so, well, what does each one do? And so this was the best way I could think of to kind of describe it to others.
That's right. So what we're talking about specifically here is when the broker is sending data to consumers or subscribers of Solace in a streaming way using our what we call AD, or it's our essentially how we do guaranteed messaging. How the windowing acknowledgement works, how the transport acknowledgements work. And this was the kind of infographic that Nick came up with specifically for that. So there's a lot of discussion internally at Solace of like, can we actually, is this actually correct? And is it, it's missing a few details, but for the most parts, yeah, this is it. So beautiful PowerPoint diagram here. We got a few more people joining. Just want to say hello. Hey, Phil, you're in Canada. Very cool. Hello. Giri, hello. How's it going out there? Bangalore, excellent. Hello. Hey, Rajiv. Hello. From India. All right. Hey, hello. Hey, Dubai, excellent. All right, so across the globe here, Nick, we're broadcasting live across the globe. So let's talk about this diagram, right? So do you want to walk us through it?
Yes, certainly. So we'll start with what was the original question, which was what would happen, or what happens when you have a consumer who is not consuming messages fast enough, and then how do you guarantee what's known as back pressure? So when you're dealing with guaranteed messages, you sometimes want to prevent more messages from lining up and queuing up when there's a point where no one is taking messages away. And so if you will consider the left side, the blue trucks, that's actually already on our broker. This is
the broker. The broker's on the left, right?
The broker's on the left. I should probably have a big sign that says broker land. Broker land on the left, which is, there is data in there. It's actually sitting in a queue so that you have a long line of trucks with their little dark circles, which is their cargo. And there's individual.
So the queue is somewhere off screen here, kind of feeding these trucks, right?
Yes. And then when it's time to go down to to a receiver, a subscriber, without going into details, the general idea is the trucks unload cargo at the port. A little boat will take it across the way, and it will be received. But that's not the whole picture, right?
Right.
So what we have initially is you have a setting in Solace known as the transport window size, and because you can't just send an infinite number of messages over the wire at once. Transport window size is defined as the maximum number of in-flight messages you get.
Yeah.
And so let's assume that we had a lot of trucks ready to go and all the boats are ready to go and they could just take them all at once, but then you'll run out of boats to take your messages across the river, so to speak. And then there's another setting known as max unact messages. So this is not always in play, but when you're doing guaranteed messaging, and particularly when you switch acknowledgement mode to manual, you have to manually say, hey, I'm a receiver. I got this message. Hey, I got this message. And behind the scenes on the software language, there's a buffer that is actually receiving these messages. And so we kind of represent that as a port, a loading dock where cargo gets unloaded temporarily before your actual code, your application code, which is the receiving trucks, can pick it up. And so whenever a message has been delivered to the port, it's unact. It hasn't been received yet. And so there's a separate setting known as max unact messages. Sometimes it's called max unact messages per flow, depending on which specific API you're using. But in general, these two things were causing a little bit of confusion because there's somewhat conflated ideas where it's how many can you put across and how many can you receive?
That's right. Like, so the typical kind of setup would be, I want to have higher performance. Therefore, I want to be able to stream. If you consider the kind of the very opposite, sending one message at a time, right? So let's say we've set up our queue to have one unacknowledged message at a time. That would essentially mean that the broker is only going to send one message, waiting for that spot in the port here to actually get removed and acknowledged before the broker over here on the left sends another message, right? So very kind of low performance, kind of one at a time, but very, very safe in terms of ordering and some other stuff like that. But yeah, you're not going to get the best performance. So obviously, we want to be able to send multiple messages across to the consumer side, assuming that they are going to be able to process them in a quick way, and therefore we're going to be doing streaming. So messages will go across, and then they're going to sit there in this buffer, essentially, this max unact. And as the consumer application reads them, acknowledges them, and processes them, putting it to its database, it's going to be acknowledging these over on this side. So in terms of the transport window, so that number can range anywhere from 1 up to 255. So at one end, a window of 1 means there's only one boat. And so it's essentially going to take one message at a time, back and forth, until this port over here fills up. So probably, again, not the fastest way, right? But we don't have to at least wait for these messages to be acknowledged. We can, as this thing fills up, that one boat will continue to go across. But you're not going to get that good a throughput, especially if you're going over the WAN. If you have, let's say, 10 milliseconds of round trip time between the consumer and the broker, you're looking at what, about 100 messages per second maximum. So as you kind of need to go over a bigger distance in the network, this river gets wider, you want to have multiple boats, and that's what the transport window is, right? So we can stream multiple messages on multiple boats over to the other side and help fill up this port over here quite a bit faster.
And also too, without going like into crazy detail, the analogy here is kind of cheating in a way, because of course behind the scenes we have the software APIs, and we actually have a transport API that's kind of coordinating the two sides of the river. For this analogy, we use what's called an agent-based approach, where the boats themselves are aware of what's going on, and they can see how full the dock is and whatnot. It just kind of makes it easier to understand, because those are, using separation of concerns, things that a consumer of Solace generally shouldn't have to worry about. Let's just assume these magical boats know how many slots are available on the receiving dock and how many boats are in flight. And so I'll posit a thought experiment. This was an actual question before we had this picture, is what happens if you have a transport window size larger than the max unact messages setting? What is the effective transport window size?
Right. Yeah. And that essentially, this was behavior that was changed probably about a year or two ago, without my knowledge, because I'm a bit of an old schooler. But yeah, previously, you would have had, if this port size was very, very small, so the max unact is like, say, 1, but the number of boats you have is like 100, you're going to get some kind of different type of behavior than if you kind of more finely tune them, right? So sometimes you'll get, I don't know, delays, but that's not the case anymore, is it?
Right. So what happens now is during negotiation, during handshake, it's what's called your effective window size. And so the API internally will be handled, and it won't actually allow you to have more boats than you have receiving slots on the port side.
Right. It doesn't make any sense, right? If your max unact is 10, you're not going to need more than 10 boats on the river to deliver messages across. They're just going to be sitting there kind of useless, and it doesn't really matter as much. It's a waste of boats, essentially, right? So.
And then there's some other nuances here, like about the boats don't actually all go back single file. They'll go over the river. When you dispatch a message, it goes right away. But the amount of slots you have available kind of are batched back. This is similar to how you go from a producer to a broker. It's not necessarily, this is just for technical accuracy. For this analogy, it doesn't really make sense. Someone's like, if I were running the dock, why would I do that? So we come up with some little side stories why they have to send the boats back in clumps. But of course, behind the scenes, it's just a networking layer. This is standard, what's it called? Like sliding window protocol.
Sliding window protocol. For those people out there that know TCP protocol fairly well, this should look fairly familiar. That's essentially what it is. We have a window of outstanding messages. This is kind of a sub protocol within our general SMF transport protocol. And yeah, that's what's happening is, the broker counts how many messages are outstanding, the transport, and as those boats come back, it'll load up more boats. So it kind of just waits until there's, enough boats. And that's kind of what it is. So what are we hoping to do with this? I think we're supposed to be turning it into a blog from what I know, but I find this is a really great visual analogy as to how streaming guaranteed messaging from the broker actually happens with our clients.
Maybe next year we'll need to have a children's book for Solace.
That's right. Like the illustrated guide to Kubernetes. All right. So very cool. Thanks for that. Let's pop over to the community here and see if we have any questions. Before that, I'm going to just check the comments. Got a few more comments here. Je vous suis à partir de la RDC. What's RDC? I don't know. What is RDC? I don't speak French that well. Window acknowledgements, always fun. Thanks, anonymous LinkedIn user. Excited for a diagram and a story that helped the discussion. Yeah, we should probably post this on the Solace community, and we can maybe spark up some discussion around it. Although we're apparently having a kind of professional version of this graphic made by our graphics department, because Nick, as beautiful as your diagram is, yeah, we could always polish it a little bit more, eh? Hello from Morocco. Hey, thanks for joining. Brokerland, yes, the broker on the left. Yeah, broker and the client. All right, cool. So here we are in Solace community. If you have any questions, you have questions for Nick and I, we're happy to talk about them. Yeah, and about anything Solace related, architecture, event-driven architecture, we'll be happy to. So please post your comments in there. Let me know what you got. Hello, Barrios. Hello. Maybe he meant RDP. Oh, yes, maybe he meant RDP. But I don't speak French, so hey, what does that in English mean? Does it mean you want to know about the RDP? I am not sure. So Michelle, if you have can you translate for us? That'd be great. Ask us your questions. Let's pop in here and take a quick look. Oh, big announcement recently. Event Portal 2.0 is now available in beta. So for those that are familiar with Solace PubSub Plus platform, we have this event portal, which helps you design, document, discover event-driven architectures, use the catalog feature to search for things. You can have your publishers and subscribers and kind of visualize all of that asynchronous PubSub flow. We started rewriting the event portal from the ground up in the back end a while ago, and we've had it as early access for us Solace people. The beta is now available. It has a much better controls around versioning. This is probably one of the biggest deltas or changes about it. So yeah, if you're on Solace Cloud, Solace Cloud, free to sign up. You can check out the whole platform. But yeah, EP 2.0 is available in beta with quite a bit of improved functionality. So yeah, be sure to check it out. Have you used it, Nick?
I did. I actually used it when it was early access still. So I haven't seen the beta version yet, but even then, I'm a big fan of things like YAML code or API specs and whatnot. I used to do code gen at my old job, automated client side code gen, and so very excited about like the new stuff that's added in the new version.
Well, you'll be happy to know, although since you're a .NET guy, maybe not, but for the last month or two, I've been working on a IntelliJ plugin for their IDE that will essentially query the portal, pulling down all of this information that's in there, your applications, your schemas, your events, and actually having it in line within the IDE in a nice kind of tabular view. And then from there, being able to, generate stubs, generate POJOs, pull down the schemas, all within your IDE. So you don't actually have to go to the portal and get this stuff. So that's what I've been learning a lot of Java Swing and things I haven't touched in a long time, but we're building a lot of kind of tooling around the whole EP2 ecosystem to help that kind of integration using the RESTful API, the Swagger API that we have for interacting with the event portal. So yeah, code gen, querying the portal, all that kind of stuff. It's a lot easier now in 2.0. So
I guess we'll be looking for a VS Code plugin soon too, right?
I have a very strong suspicion that someone will be writing one soon. Other members of our team are writing a full-on TypeScript wrapper to basically pull down the Swagger, wrap it up, and be able to do a lot of kind of to help simplify interactions with the portal. But once that's kind of finished up, I'm sure a VS Code port or version of my plugin will be kind of made for there. So yeah. Got questions out there? Please post them up. I want to see them. Is the window size set by the publisher? Okay, so that's a great question, kind of related to what we were talking about. The diagram that we showed was from broker to consumer, right? So there's a similar transport window, AD, it's called AD transport window on the publisher side as well. And yes, that is set by the publishing application. And it essentially, just the same way, it means how many messages, how many persistent messages can be in flight between the publisher, the producer, and the broker as it receives them. So I think by default, most of our APIs have it set as 1, not all of them. So what that essentially means is as I'm publishing messages, if I'm going over the WAN and I'm publishing at a very high rate, I'll actually get back pressured because it's going to take a little bit of time for the round trip to go to the broker. And the API says, well, you can only have one outstanding message before waiting for the message ACK to come back. I have a whole YouTube video on ACKs and NACKs that I can post a link to in just a second. But yeah, you're not going to get very good performance. Whereas if you make that window bigger, right, you'll get higher performance. Give me 1 second here. I'll see if I can find that that link. Just so let's see here. Nick, any other thoughts on publisher window size? Like things that you think gotchas maybe?
No, off the top of my head, I believe some of our APIs, like the JMS-based ones, if you're using JMS instead of SMF, it's always going to use a window size of 1 on the publish. And then although the window size is set by the publisher, there's a mirror image. There's 2 settings. There's also the window size set on the receiver.
That's right.
Although they're semantically the same, they are separate settings. So if you are a receiver, you say how much window size on the downstream versus on the upstream.
That's right. That's right. All right. Just found that link. Now, one thing that I guess, so yeah, if you're using JMS 1.1, when you're doing a persistent publish, it's blocking. It's a blocking call. So within the API, your API send call will not actually return until the message has been acknowledged by the broker. That's different than most of our kind of our native APIs, where it's a streaming based API. So when you call send, it gets written to the socket. The send call returns, and then asynchronously, the acknowledgement is going to come back a little bit later, right? So here's let's see, I'm going to put this in, publisher, ACKs, and NACKs video. I'm just going to post that there. Hopefully that gets through. Yeah, so if you want to check out a little bit more information on the publisher side, streaming windows, and that kind of thing, check it out. There's some gotchas there that you might want to check out as well. So yeah. Thanks for the question there, Rajiv. Giri. Oh, excellent. DRC, Democratic Republic of Congo. Michelle, very cool. Thank you for joining. Now that I got my translation, thanks, Giri. I should brush up on my French. Awesome. All right, so let's take a look at some questions on the community while we're waiting for some live questions. Let's see here. Yeah, how about this one? I was going to take a look at this one earlier. This one actually hasn't been answered yet, so let's just pop into this for just a second. Hey, Nick, it's a finance question. You work in the finance side, so hey, this maybe is more applicable to you too. We're using Solace to push market data to client applications via direct messaging. Okay, so that's our other quality of service, right? So people, we just finished talking about guaranteed messaging and all the acknowledgements that are happening. In direct messaging, it's more of a fire and forget, right? The publisher just sends a message and it might get lost on the wire if the app crashes or the TCP, the network goes down, and same on the receiver side. Messages are not queued and buffered as much as using guaranteed. I've noticed that some clients struggle to consume data at the same rate due to connectivity issues. All right. When network dips occur or you reach your Wi-Fi dead zone, some clients fall behind on market data. Right. You always want to have access to the most recent data, I guess. In order to alleviate load, we have implemented alighting on Solace. All right. I wonder if people know what alighting is. So we can describe that very quickly. This does work, but still seeing some clients struggling to keep up due to connectivity, right? So if your network is going bad, the input is obviously going to be significantly impacted, right? So I was thinking of potentially monitoring the latency. Does the broker have per connection data around this? So monitoring from the broker. If so, I would like to pull this data and disable the client when this happens. So basically pulling the broker's stats to find out if a client is slow and maybe kicking that client off. That's one way to solve your latency problems, is just to kick off, disable the client. I guess, yeah, disconnect the client if that's occurring. So let's talk about alighting really quickly. Nick, have you used alighting yet? It's a fairly not as well known feature in Solace for a lot of people.
I've never used it. I'm familiar with it. We've had this conversation before. This is typically relevant for front ends. So that's exactly what this sounds like. We're having a front end application that, you only need data as fast, essentially, as a human can process it at this point. This is for human consumption, not for like a service to consume. So even though market data, it's kind of fire and forget, sometimes it's firing too quickly. And so sure, a smart pricing engine needs to know all the data. But if you're a human watching, the last value trade or something of a particular stock or ticker, you only need it as fast as you can process it. So alighting is essentially downsampling, if you will. That you say like, well, give me all the updates for this ticker, but only 10 times a second, please. If it changes any more frequently than that, I don't need all that payload, because particularly like on a JavaScript front end, if you get so much extra data and you don't even have time to render it or show it on the screen, there's no point. You're just adding extra load to your single threaded process. So alighting is essentially downsampling. So with regard to the question about thinking of potentially monitoring latency on the client, that seems to be a pretty solid approach, mostly in that if you are having connectivity issues, there's not much that the broker is going to be able to do to, at line or tell you. Let's say your Wi-Fi has dropped out completely, but your WebSocket connection hasn't quite figured that out yet. So you'll be showing stale market data, and the user doesn't necessarily know this at the time. So yes, latency monitoring on the client side is the correct approach. The question is how do you go about doing that? I don't believe you'd be able to fetch per connection data from the broker, but it's also not likely that you'd get that in a timely fashion anyway, because you've already started to lose your connectivity.
Well, I think I assume they're talking about building a management app kind of like in their core, so that it's not going to be impacted by that. So kind of some kind of statistics, SEMP, probably using SEMP to gather data from the broker. There is per connection latency data. The thing is, I just don't know how well it would show if like a socket is hung, or how responsive it is, and how aggressively you can pull that, because you're actually having to query every single client connection and kind of find out what the round trip time is. There is a SEMP command that you can do this with, but it is a little bit heavy, shall we say. So depending on the number of broker or clients that you have, it might not be that great. One thing around alighting is, you're telling the broker to kind of like throw away stuff. If the broker's receiving 10,000 messages a second on a particular topic or a particular symbol, you only want to receive 10 times a second or once a second. The broker is throwing that stuff away. But there could still be messages built up on the broker. The broker does have a buffer for every single consumer, right? So it's somewhere kind of in memory. It's memory only. If a client is falling behind or the traffic is bursty, that buffer can be used to store data. It's possible that I've just thinking out loud here, tuning that buffer down, which is set via the client profile. They call them egress queues. Tuning that egress queue way down in your client profile would essentially mean that the broker is only buffering the very, very last couple messages that it has received. So if you start to fall behind and that buffer starts to fill up, making that buffer really small would essentially mean that the broker is throwing a lot of stuff away. So that's without using alighting. However, alighting does kind of mean that you're getting that kind of per topic discarding behavior. So a little bit more sure that in case you have lots of different topics and maybe there's one that's flooding the whole network. Off the top of my head, speaking of market data, often when you first connect, you need to know the kind of last tick that you saw on a particular symbol or the last kind of known pricing. We have a product called Salt Cash that a lot of our kind of finance customers use. But also, if this is streaming out to client applications, third parties, I've heard of a lot of people using MQTT in QoS 0 for this kind of thing. MQTT is an open standard, primarily used in IoT, but it has a lot of similarities to Solace messaging in the fact that you have a nice descriptive hierarchical topic, so you can have very kind of fine-grained topic filters. And by default, it has a built-in retain flag, where if you are publishing market data, as you connect and you subscribe as your kind of QoS 0 MQTT subscriber, it would automatically send you the last retained message on that tick. So rather than having your third-party clients use a Solace API, they could use an open standard MQTT API, and they could receive the last tick on any particular topic that they receive. The only problem with that is it can't use alighting, so maybe that's not as good a solution, right? So, yeah. Anyway, I'm going to come back and post some text onto this later on after we finish our call, but that was some good discussion there. Yeah, let's see what else we got. Let me turn off my little ink thing. If you like this, I can draw on the screen. I was going to try to draw kind of what alighting was. The broker has this window that basically it'll keep the last message in that window. So every like 1 second, it'll send just the last message on that window. I was trying to, it's hard to draw with the mouse though. So yeah, let's clear that out of the way. All right. Come on, ask us some questions. Give us some, let us know what's on your mind. Developing Solace applications, publish, subscribe. How about, more questions on guaranteed round trip time. Oh yeah, I checked out this one a little bit earlier. Let's check out this. So a DMQ, Nick, what's a DMQ in Solace?
A dead message queue.
All right. Scrolling away here.
So obviously, with a little context for those who maybe you know that the phrase, what it means is that messages that go into Solace don't always, but you can always designate a TTL, which is time to live or time to live. So messages, if they're stale or outdated and they haven't been processed for a while, there's two modes in Solace. If you say, well, let's discard this message, it's not good enough, it's out of date, you can either just throw them away. That's one option. But then the other option is to throw it into the DMQ and say, well, I didn't get to processing this event in time, so I probably need to either keep track of it or perform some other post event on it. So a great example would be like an order wasn't received in time, so the person making the order kind of needs to know that, and so it'll go into the DMQ, and then you could pull it back.
Right. So in Solace world, there are two ways to expire a message to DMQ. Yeah, one is with TTL, time to live, which either you can set on the queue in terms of like the queue cannot have anything that's older than 30 seconds or an hour or whatever. This is a great feature to use in your development environments where developers are just publishing to random queues and then leave them sit there forever. Queues fill up and things stop working. So having queues automatically clear themselves out is kind of a nice feature. But yeah, also maximum redeliveries, right? So if you have a poisoned pill message stuck at the head of your queue that keeps getting redelivered to your application and it can't process it, crashes and comes back up and reads that same message. We call it head of line blocking. You can have that message go to the DMQ. So essentially, it looks like Bikash here is saying that they got things configured. They have your main queue and their DMQ, and they're trying to make sure that they have TTL enabled. Let me just hide that. We have TTL enabled, which you need to have turned on, and a maximum TTL of 3 minutes. Now, the only problem is it looks like it's not actually working. Attempted to move to DMQ, failed for all expired. Something that I'm missing here. All right, so let's take a really quick look, see if we can help out Bikash here. So Tom is like, hey, where's Tom? I haven't seen him in a while. Check out if your DMQ is able to receive messages, can we actually publish to it? Right, the DMQ is just a regular queue. It might be shut down. If the queue is shut down, it's not going to be able to receive any data. So yeah, here's the main queue. All right. Lots of messages in the queue. DMQ is hash DMQQ. Okay, that looks all good. And here's the DM. Okay. Some of my. All right, Nick, do you notice anything that might be miss?
It's a very, very subtle thing.
Very subtle thing.
Yeah. It's that pound sign or hash sign, depending on what English we're speaking.
That's right. Octothorpe is another one. That's Emerson came up with that. I'd never heard that word before, but now I know it's part of my lexicon. So right, by default, when you configure a queue in Solace, it has this particular DMQ. When you configure a queue, this is the default DMQ configuration. This hash dead message queue. That's almost a bit of a legacy throwback to when we used to only have one DMQ per message VPN or per service. And, we changed that way back in like 6 dot something. But you can specify every queue can have its own DMQ. But yeah, one thing to notice is on Bikash's actual dead message queue, it's just called dead message queue without that hash. So there's no queue that it is going to, and that I'm pretty sure is why the that's happening. So that should be a pretty easy fix. I guess I'll have to come in here and add a comment. I could do it live on air. No, it's too much typing. I'll leave that for now.
There was a question that came in, by the way, regarding
Oh yeah.
DMQs.
Let's see here. There you go. Gary, can we build business logic around DMQ like any other queues? Anything special about it? Business logic. Okay. So I mean, I think this could be interpreted in a couple of different ways, but I'll just give it my thoughts first, and Nick jump in here. So DMQs are just regular queues. So you configure them the same way. They can have the same kind of same setup for exclusive, non-exclusive, all that kind of stuff. But typically, consumers that are listening to a DMQ are not your standard application that's listening to your main queue. Simply because if a message gets to the DMQ, it means that something went wrong. It expired. If a message is down here in the DMQ, that means either it was a poison pill that got stuck, or maybe it timed out, and you might want to do some special processing later down here. Perhaps, some kind of logging application, perhaps some kind of republisher application. You might want to say, I want to try to publish that message again. So yeah, I would say it's going to be different than your kind of standard production app that's listening to your regular queue. You're going to have some kind of retry or logging mechanism listening to your DMQ. That'd be my take on that. What do you think, Nick?
Yeah, I think that's captures the question intent as well. I mean, like, can you do other things with it? I mean, sure, you could put a TTL on the DMQ queue and DMQ it again if you want to, or just throw away the second time. I mean, there's I suppose there's nothing special about it. It is, as you said, just a queue.
It was using this particular setup was actually the way that users of Solace applications did delayed delivery as well, until we came out with the delayed delivery feature. That's all actually built in now. But there was a lot of use cases where you publish a message into the broker and you don't want it to be consumed until, say, 30 seconds later. And so you could configure a queue here with a 30-second TTL with nobody listening to it. Like, this is just your buffer 30-second delay queue. And then it would expire to actually your actual queue, right? And then you have your business consumers over here. And so, the broker would hold on to every message for about 30 seconds, kind of giving it delay. So if you wanted to have some kind of, maybe bronze tier users of your system get like a 15-minute delay feed, that would have been one way to kind of implement it, is have a queue here with 15-minute TTL before going to your DMQ where you could actually read messages. But yeah, we do have a delayed delivery feature now built into the broker, but that was another kind of cool use case for TTL and DMQ kind of behavior there. So yeah. Follow up. Curious to know if we have a delayed publish can be accompanied with TTL and DMQ converse. Right. Well, I think we just talked about that, right? So then delayed delivery, yes. So that was a new feature that we added, I think last year, was around delayed delivery. If I can remember all my release notes, I could probably give you the exact version, but yeah. So one thing I guess I would like to mention as well is we have a lot of users of Solace that, kind of, if a message lands in this DMQ, it just sits here. Maybe they don't have a consumer, right? They might come in temporarily connect and look at it, or they might want to just browse it and leave it in their DMQ. Typically, you might say, well, I forgot to fix my production consumer here. Maybe we had a version upgrade or we changed the schema, and I'll go away and actually fix. Let me see, I can draw it here. So this is my consumer here. It's trying to read this message. It doesn't read it, and eventually it goes to DMQ. I might go and fix this consumer and redeploy it, and now say, all right, now I'm ready to actually receive that message that had a problem. So in 10.1, I believe, the kind of most recent Solace broker that just came out, we have a feature built in now where you can actually copy a message from the DMQ back into your regular queue. And my colleagues Tamimi and Ray actually did a video on this. I'll post up a link to it in just a second. But yeah, this has been a feature that's been asked for years. Historically, you had to actually consume the message from the DMQ with a client app and then republish it back into the original queue. So kind of going outside of the broker into the client space and back in. And now we have the built-in ability to just kind of move that message in the queue itself. So very useful in my opinion.
Can I ask that? That's a new feature for me.
It's a brand new feature. Yeah.
Oh, okay. Well, I guess my question then is maybe as like a follow up. Then where in the queue does it reinsert into the primary? Does it go back? If it was a head blocker and it went to the DMQ, does it go to the back of the queue, or does it kind of preserve the original order?
It does not preserve the original order. It'll go to the back of the queue, right? So it'll be stuck behind a bunch of other stuff. So it's quite possible that you'll get out of order messaging. And that's just kind of almost common sense, because once that, if that message was stuck at the front of your queue, once it DMQs, once it moves out, whatever's behind it will just start to come through, right? So if you have order dependent messaging, and you definitely don't want to have a message, kind of an old message, pop to the back. Well, then you're going to have to think about different ways of handling that, right? Either leave that poison message at the front of your queue and block forever to guarantee that you won't have any out of order, or just make sure your consumers are able to kind of notice when things are possibly missing. Maybe if that poison message was the start of a stream of related data, and you receive the second one, you say, okay, something's wrong with this particular stream, which you can correlate using some kind of unique identifier, then, you could build your apps to handle it that way. So I'm just going to post up, this link to the live stream that my colleagues did, which talked about all the new features that were in the broker. There we go. Yeah, check that out. It is a great kind of quick view, and there's chapter markers in the description, so you can kind of jump around if you want. But if you really want to see the feature that, you can move messages from your DMQ back into your queue, or from any queue to any queue. Basically, copying from message from any queue to any other queue, you can now do through the broker using either the GUI tool, the PubSub Plus Manager, or using SEMP, which is our RESTful API. All right, cool. All right, delete that. Actually, I'll just leave it for now. Move this out of the way. Okay, so I will post an answer to Bikash here once we get done our live stream. Any other questions out there in Solace land for Nick and Aaron? You have two fairly experienced Solace people live on air, ready to answer any questions that you have. Let's hear them. Let's post them up in there. All right, taking a look, just talking about acts, continuing with our topic of conversation here. This is a good one. Let's see. We have a message consumer listening to two different queues. So you'll get two different flows. I guess that's one thing we kind of glossed over in our diagram there, Nick, was, when a client binds to a queue, when it connects to that queue, there's a flow, which is like a kind of a virtual pipe. And that's actually where those boats are actually going around in, right? There's like the transport window is per flow. And the max on act is per flow as well. So if you're connecting to multiple queues, you're going to have multiple flows inside your one TCP connection. Here, the consumer is not just consuming messages; it also stores and processes the messages. Well, good. I assume if you just, you want to be able to do something with the messages when you receive them. You're not just throwing them away. And it would be ideal to send an acknowledgement only when the consumer has successfully stored and processed the message. Yes, please. That's a huge thing. I have a follow-up to my Acts and Knacks video, which was the publisher side, where on the consumer side, as you're receiving messages, do not acknowledge the message until you are fully processed it, stored it, you've sent it to your database, your cloud native app, and you've gotten that commit okay, that acknowledgement from the far side. Do not acknowledge back to Solace until, it's safely stored. That is, I don't know. That's just very important. I don't know how to say it, otherwise you could be losing data, right? If you act the message on Solace and it deletes it and you haven't actually stored it or processed it yet and your app crashes, that message is gone, right? So you don't acknowledge it until you're done with it. Can't stress that enough. Now that you have a consumer consuming for multiple queues, you need to know the flow instance at the time of sending the acknowledgement. How to get the flow instance, or at least which flow when the message was consumed. All right, without reading the comments, oh my gosh, there's quite. I'm going to say that you don't actually need the flow if you have the message object. When you acknowledge the message, you just say message.ack. You can call there's a instance method on the actual message. I see Nick thinking there. He's going to double check me. I'm 90% sure that you just acknowledge on the message, and you can do it from any thread. And as long as your connection is still up, that flow is still there, it will send it to the broker. So I am very curious to see if that's the case. Application tracking belong to which flows? And okay, so I'm wrong. That's interesting. I don't believe it. Supposed to receive message.
This is the C# API, by the way.
Is that different? Yeah. So I'm used to JCSMP.
Yeah.
And
I was grinning because
through Java glasses, which is maybe incorrect. So you're the C# guy. What do you think here?
Yeah. So I was grinning only because if you had asked me any other day of the week, I probably would have known off the top of my head. But
all right.
just yesterday I was on a client call where we were manually acking messages on a flow. And in the .NET API for our SDK, there's the flow object and there's the message object, and the ack method is found on the flow instance, not on.
Oh, that's different. Okay, that's good to know. Is that the same in C? Do you know? Because the C# library wraps the C API, so I'm kind of guessing maybe.
Definitely, maybe. I don't know that.
Okay, so that's very interesting. So yeah, apologies out there, Lad Piyush. I'm wrong. If you're using Java, you don't need to worry about it as much because you just call message .ack on the message object itself, and that's all you need to do. So what they're suggesting, Ragnar here, who's one of our top-notch internal R&D API people, is that you'd build yourself a little helper object, I guess, and keep track of them, right? So just with a pointer to each, and then you'll know which flow it came from. Otherwise, use a transaction. That we try to avoid transactions if we can, due to possible some overhead. But if you're doing non-transactions, there you go. So you just have to have a little helper object, a little helper class. Blah 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 blah. Oh, this is my blog. Sticky load balancing pattern is mentioned in. For those who haven't seen it, this is a question that we get asked a lot, actually, when Kafka people are saying, hey, how do you do consumer groups in Solace? How do you shard an incoming message stream into multiple parallel queues so that, on each queue you have a guarantee of order for a particular, partition ID, for example. Well, this talks all the different ways that Solace does consumer scaling. If you want to check it out, here, I'll drop the link into the chat. I'm posting lots of links here. So anybody out there wants to read it, we talk about, how to do that. Now, the cool thing is that Solace is actually building a feature called partition queues. So inside the broker, it's going to be doing this stuff automatically. But as of today, and for the last maybe 10 years, a lot of our very high performance guaranteed messaging clients that need sticky load balancing, for a payment gateway, you want to make sure that the cancel message goes to the same gateway that the new order message goes to, right? You don't want to have it load balanced to a different gateway. They use basically one level of the topic hierarchy as a partition key. So here's my little diagram. You can kind of see that I have 4 queues, so I kind of have multiple 4 different partitions. But I'm actually using the topic, so the third level is actually a kind of a mod 8. So there's 8 different partition groups, consumer groups, I guess, mapped to 4 actual queues, and those get mapped to actually 2 consumers. So you can, scale up the number of consumers. You could have 3 consumers, 4 consumers, reading from those 4 different queues. And then if you actually needed more scaling than that, you can make new queues and rebalance your topics into the thing. So very similar to Kafka in the sense that you have a partition key when you publish a message. In the Solace world, it's just kind of one part of your one level of your topic. So have you seen this diagram, Nick? Does this make sense?
I've not seen this diagram. I really like it because when I was learning about the upcoming partition queue feature, I was thinking in my head, like, couldn't you already do this if you just put on the topic? But obviously with the management side where you have to manage that the queues exist and whatnot. But with a little bit of boilerplate in your own code, you can kind of do the partitioning feature. But it was nice to hear that it's going to be like a first-class citizen too in our APIs and in the broker.
Very, very similar to the DMQ TTL combo for doing delayed delivery. Yeah, you could roll your own. And as with a lot of cool features or new features, often you can implement them in ways using existing features that maybe weren't actually meant for that, but putting them together, you can kind of do some cool functionality. So yeah, that's exactly what this kind of pattern was built for. And the nice thing is that kind of topics and subscriptions in Solace World are quite cheap. So I could actually have, in this case, I only have 8 partitions. So like a maximum I can scale this up to is 8. But you could have 250 or 1,000, different topic subscriptions, which would, even if you only have 2 or 3 queues, to start with, you could essentially allow it to scale up quite a bit larger without having to change your publisher. Obviously, your publisher needs to know how big your key space is. So if you kind of need to scale up the publisher, then it's better to kind of start large and with a large partition key space, even if you're only kind of your message rates don't really require it. But yep, it does require a bit of logic in terms of setting up queues, having the topic reflect the key, stuff like that. But yeah, it's coming soon. Partition queues, stay tuned. I don't know exactly when it's coming out, but it is coming. So anyway, all right. So just to tie off this question here around multiple flows, which now I know the answer to for the C# API. Thanks for that. Yep. All right. So in the register event handler, blah, blah, blah. All right. No document saying the sender is actually a flow. All right. So looks like we have a little documentation bug to kind of follow up on here. So, all right. Hey, Nick, is there a question that you have seen? I've kind of picked a couple here. Do you have one?
Well, not that's actually on the community. This was actually from that customer call that I was dealing with .NET.
Oh yeah, okay, yeah. Let's hear about that.
So it's just related. It's this perfect follow on to the question about flows and connections, and this customer was asking about like what is the best like pattern or technique. So they have a multi-threaded consumer, a single process multi-threaded consumer, but they also have multiple consumers that they're going to spin up and spin down. And the question was from a both performance and maintainability perspective, like, is there any benefit to having for one, multiple connections per process,
right,
to the broker? And then likewise, if you're consuming from a single queue, is there a reason to create more than one flow? Or is it better to just stick to one connection per process, one flow per queue?
That's some good discussions there. Where do you want to do your scaling? Within one app or at the app level? There's lots of ways to skin a cat, I guess you could say. There's lots of answers here. So what did you end up discussing with them? Like, I have some opinions, but
So my recommendation was, first of all, when it comes to number of connections, that in general, because this was a cloud implementation, that you're not necessarily going to get better performance by just connecting to the broker multiple times. That ultimately your node in the cloud somewhere and this broker in the cloud somewhere are going to have a fixed total bandwidth that's going to be allocated and also throttled by your service provider, your cloud provider, so that there's really no benefit, that you're more likely to be compute bound than you are to be network bound. So opening up just multiple socket connections generally won't do much. I mean, unless you're connecting to different brokers for some reason.
Oh yeah.
There's no reason to have multiple open connections to one broker. Was my recommendation.
From the same app, right? So,
yeah, from one app, from one process space.
Yeah.
I don't think there would be any benefit. That's just my hunch. And then with regard to the question of flows, likewise, that unless you have some wrapper class that makes it more convenient there's if you have a single subscription or single queue you're bound to, there's no benefit to having multiple local copies of that flow in memory. That your multiple threads can be servicing that single flow, and that there's no reason. So in my mind, my hunch is that it's one session or connection per process, one flow per source queue. That was my take.
So I'm just trying to pull up a thread here. So here's one thought. So if you have a single connection with a single flow to a single queue, and then a single thread processing those datas, obviously, yeah, you're going to run out of, you're going to be rate limited by how fast that one thread can spin. So as you start to hit, kind of performance limits, you're like, all right, I need to scale up. And how are we going to do that? The probably maybe not the easiest way to do it, but one option is to use what's called the reactor pattern, where within the app, you will have multiple application-owned threads that are able to process messages kind of independently, and those could be pulled off a single queue with a single flow, and then dispatched out to those multiple kind of helper threads, right? That they can do it. Load balancing, though, you're now dealing with possibly out of order messages, unless you kind of do something like that consumer group sticky load balancing thing that we talked about earlier. Alternatively, the problem with that is if you end up in a situation where one of those processing threads has a problem with the message, right? Let's say it throws an exception and something bad happens, and it closes your flow. It's now going to impact all of those other processing threads. So you could almost think maybe it's safer to have one flow per thread, because sometimes threads are, depending on your broker, you might have lots of flows available to you. That way it kind of, the responsibility, like per each thread has its own flow. Therefore, if something goes wrong with that one thread, it's not going to impact another thread that is having a problem. That is one consideration as well.
So like all engineering, the answer is sorry. Yeah, I was gonna say, like all things engineering, the answer is it depends, right?
It really depends. Yeah, it always depends. Yeah, and then of course, yeah, you could do the microservices Kubernetes scaling technique, which is just to scale up your little app, right? So each consumer could be just a tiny little one flow, one thread, one socket connection, and if you need more, performance to drain out your queue, yeah, you just run multiple copies of your app, assuming you have a non-exclusive queue, because otherwise, yeah, if you're using exclusive queue, only the first consumer is going to get a copy of it. Let me just, I couldn't find a diagram talking about what I want to talk about, but this is the YouTube video where I kind of go into the reactor pattern. I'm not going to play it right now, but yeah, it basically talks about how to do multi-threaded applications within multi-threaded consumer within the application space by having a multiple threads pulling off kind of a shared queue. But yeah, as with all things, yeah, you would have to kind of test it, make sure. I think maybe the length of time over your WAN might have something to do with that as well. Maybe having multiple TCP connections might give you slightly better performance. I don't think so. Maybe in certain extreme cases, maybe. But yeah, if you're going over the long distance over the WAN, maybe having multiple parallel TCP connections, and each of those connections is connecting into the queue to kind of parallelize your message flow, could give you better performance, but probably just makes it a lot more complicated, right? So yeah, interesting. Well, hey, listen, we're at the top of the hour. It is 1 o'clock here in Ottawa. That's it for this month. Nick, thank you so much for joining. I think we talked about, I'm going to have to tag up this video on YouTube with all about guaranteed messaging and all about ACKs and NACKs flows, because we certainly talked about it, quite a theme that we had this month. So thanks for joining. I hope you had fun.
All right, it was great. This has been a lot of fun.
All right. Thanks to everybody for watching. Thanks for your comments and questions. I'll be back next month live, probably from Vancouver. I'm going to be in Vancouver next month. So yeah, stick around. Make sure you check it out. And thanks for watching. See you next time.